Hey, fifth grade Broncos. This is our science lesson for Thursday, August 20th. And let's go to the whiteboard and see what our agenda is for today. Okay, so today I'm going to show you what your Jamboard assignment is for the day. And then we're going to talk about our lesson. We're going to do our lesson and talk about the activity you're going to do today. You're going to do your experiment today, and you're with your paper airplane. And then I'm going to show you how you're going to document everything into your science journal. So you're going to document all your data and your reflection in your science journal from our experiment. All right, let's get started. Now remember, to get to the Jamboard, you're going to click on the link in your assignment, and then you're going to click that square box in the top right, and you will come to this page. And then question number 1 you're going to answer with a sticky note is, how can you make sure your experiment is fair? You only have to answer this question one time, but I do have it on 2 different pages to have plenty of room for people to respond. So respond on either page. Question number 2, what things would make your experiment not fair or incorrect? Can you think about that? What things would you do that would make your experiment not fair? Okay, so in our lesson today, we're going to think about what makes a good experiment. Now, we are doing a simple experiment this week, and as we do it, we really want to think about this question of what makes a good experiment. What do you think would make a good experiment? You can shout it out. Well, one thing is that would make a good experiment is if it's interesting. It's good if it's something you're interested in, right? So if you love paper airplanes, I bet you think this is a great experiment. If you're not that excited about paper airplanes, then you probably are so-so on it. And that's okay. A good experiment is something that's going to be interesting to you and to others. Another thing that makes a good experiment is if it's organized. If your experiment is tidy, if you have you've kept track of you just follow the steps, and you've been writing everything down, and you have all your setup items, and you have determined which things which is your independent variable and what is your dependent variable and what is your controlled variables. And then when you do your trials, you are going to take good notes and write things down as you do them. And then at the end, you want to reflect, and then you're going to write your response. And you put all that together and in a very organized way that people can read easily. That's going to make a good experiment. Another thing is repeatable. And so that means that it's set up so that you can do it again over and over and over again if you wanted to, and other people can take your experiment and they can test it and test your hypothesis. Now, another thing we talk about is being valid. Do you know what being valid is? It also it means accurate. So if you have a valid experiment, it means it's accurate. And some of those things are going to be that there's only one thing that's changed, and you've written all your numbers down correctly, and you've done a good job of when you measure it correctly. All those things are going to make it valid. And so when you have your experiment, it's organized and repeatable and valid, other people can do your experiment and they can get the same answers as you. And so then everybody knows, and the more you do it, if you do something once, it may be correct, it may be accurate and valid, or it may not be. But if you do it 100 times and get the same answer every time, that's really going to show that it's valid, it's accurate. And the last one is going to be fair. Do you have a fair test? Is it fair? And this is all going to come back again to if you're being organized and if you only have one thing that changes. You know, if you were to test your airplane today and you change the design of the airplane, you know, it could make it so a light toss is going to make it go further. You know, so if you change, you're not going to know what made the data happen if there's several things that changed. So really having a fair test means that you really are going to have an accurate results, and you're really going to set it up and follow it exactly as you said you're going to. All right. All right, great. So now today, what we're going to do is you're going to do one trial of your experiment. And so what you're going to do is you're going to take your paper airplane, right? And you're going to get your pencil and paper out. And you're going to throw the plane lightly, just very gentle throw, a light throw, maybe even just barely throw it at all. And when you barely throw it at all, you're going to measure with your measuring tool you picked out how far it went. And then you're going to write that down on your piece of paper. And then you're going to take the same paper airplane and you're going to throw it hard as you can, and see where it lands. And then you are going to measure that distance. All right. And you're going to write it down. And then once you have that 2 data points, where you're going to take the one for the light throw, how far did it go? And the one for the hard throw, how far did it go? And then you're going to take that and you're going to go open up your science journal, and we're going to document everything in the science journal. And then you're going to, based on the data you got, you're going to see if your hypothesis was correct. That's the first thing you're going to do. You're going to, after you put in your data into your science journal, then you're going to determine if your hypothesis was true. And then the last thing you're going to do is you're going to write a reflection on your experiment. All right. And we're going to go to your science journal. I'm going to show you in your science journal. That's probably going to make more sense, and we'll go from there. All right, let's head to your science journal, and I'll show you what I want to see in there for your experiment.
Okay, now remember to click on your journal. To get into there, you're going to click on Keynote and open up your journal. And then the first thing you need to do is to add a blank page by putting that, hitting that plus sign in the bottom left. And then you're going to add a heading. And the heading you're going to add, because we're continuing our experiment, is you're going to add your data. Now at this point, before you get to this, you should have already done your experiment and have your data written down. And all you're going to do now is you're going to document and record the data in your notebook. Now I am going to add a chart to put my data in, because that's going to make it really nice and tidy in my notebook. You do not have to do this, but I do want the data to be in there very neat and orderly. On the left side, I'm going to write trial, independent variable, and dependent variable. You only need 3 rows and 3 columns, so you can click the paintbrush and you can change that to 3 rows and 3 columns if you want to play around with this data chart, but you don't have to do this. And then in paintbrush, you can also hit the hit cell button, and then you can add thick borders around your data. This is just something fancy you can do. You do not have to do this. You can just type it into your journal, or you can draw the lines yourself, but this is just an option for you. And then you can resize the whole thing and center it, just however you want it to look. You're only doing 1 trial, so just 1 across the top there, 1 trial. And then your independent variable is you had a hard throw and you did a soft throw. And then your dependent variable, this is how far it went. Your measurement is going to go in here. So this should be just from your piece of paper. You're just going to copy it into your journal like this. Now after you recorded the data from your experiment, you're going to write your reflection. And you're going to just add a text box that says reflection, and then I want you to answer 3 questions. Please write and answer these 3 questions into your notebook. Was my hypothesis correct? Was it a fair test? What could I do to prove it is a valid experiment? Take some time to reflect on your experiment before you answer these questions, and once you're done, be sure to hit submit. Great job, everyone.